In the second lesson in this chapter, we make the connection between square roots and exponents. And the importance of that is if we know that a square root is really just an exponent, then we can apply all the power rules that we discussed yesterday. So for example, if you take 9 to the 1/2 and type in your calculator, you'll see that it is 3. Or in other words, the square root of 9. So a rational exponent can be written like this. If we have b to the 1 over p, we'll make it q actually, we'll make it q. 1 over q, b is equal to 1, b to the 1 over q is equal to the q root of b. So in other words, if I say x to the 1/2, that's really just the square root of x. Or if I say x to the 1/4, it's the 4th root of x. What this allows us to do now is to write things like this: b of p over q, which is now equal to, this would be the radical, q would be the radical, and p would be the exponent. So the q root of b to the p power. So for example, I said x to the 3/4, this can be rewritten as the 4th root of x all cubed. And it doesn't matter which one you do first, by the way. If I said x to the 1/8, or I'll make that 7/8, it would be the 8th root of x all to the 7th. So let's do some examples before we can solve some equations. So examples. Number 1. If I said 8 to negative 1/3, well, first we need to find the cube root of 8, which is 2. And flip it. So it's 1 over 8 to the 1/3, which is 1 over 2. Next one. 16 to the 1/4. 16 to 1/4, this means the 4th root of 16, which is 2. If I said a very common problem here, 27 to the 2/3. Well, the cube root of 27 is 3, and 3 squared is 9. If I say something like the 6th root of 27, a to negative 1, b squared, all raised to the 4th. We could rewrite this as 27 a to the negative 1st, b squared, all raised to the 4/6, or in reality the 2/3. And now we can distribute this. 27 to the 2/3 is, we just solved up here, 9. This becomes a to the negative 2/3 and b to the 4/3. Going by the properties yesterday, we can multiply this in. So this simplifies to 9b to the 4/3 over a to the 2/3. If I take something like the cube root of x times the 6th root of x divided by the 5th root of x, something which would have been really impossible to do anything with until now, we can rewrite this as x to the 1/3 times x to the 1/6 divided by x to the 1/5. If we add these exponents, we end up getting x to the 3/6 or x to the 1/2 over x to the 1/5. And now if we subtract these because we're dividing, that's equal to x to the 3/10. One last problem before we switch gears a little bit here, number 6. Let's take 3x to the negative 1/3 times x to the 1/3 minus 4x to the 4/3. We can distribute this in. Remember that negative 1/3 is only on the 3. So this is 3 times 1, 3. X negative 1/3 times x net 1/3 is 0, x is 0. I'm going to write that in even though that is 1. Minus 12 x to 3/3, which ends up being 1. So we end up getting 3 minus 12x. So you can see that the rules from yesterday apply to what we do today. So now let's flip this. And one of the main focuses of this chapter is to solve equations. So let's solve some basic equations. Number 1. 2 to the x equals 1 over 16. You can probably do this one in your head, but my goal is to real quickly go over a process for it, because I want to use this process throughout the course. We can write this as 2 to the, since this is a 2 to the x, we can write this as in terms of 2. This is 2 to the 4th power. So this is 2 to the x equals 2 to the negative 4th. And therefore, the only way these are ever equal is if the two exponents are equal. So x equals negative 4. Again, that problem may have been too easy. But if I take a problem like 8x minus 1, 8 to the x minus 1 equals the square root of 32, this might be a little more difficult to do in your head. So we've got to think of a power, or a number, our base, that gives us both these numbers. This here is 2 cubed. And this here is 2 to the 5th. And I'm going to write the radical as an exponent. So you can see now the exponents must be equal. So this is 3 times x minus 1 is equal to 5 halves. So when we solve this, we get 3x minus 3 is equal to 5 halves. We add the 3 over, and we get 11 halves. So x equals 11 over 6. Let's do 2 more problems. And these 2 problems involve something slightly different. If we take 4x to the 3 halves, is equal to 32. You can divide by the 4, that's the easy part. But in this part is where people get mixed up. We have to get rid of 3 halves of the exponent. If I have x squared here, you know to square root this. So if this is the exponent, we just do the reciprocal, because the reciprocal of it would cancel this out. So we're going to raise this to the reciprocal power, and raise this to the reciprocal power. So we get x equals 8 to the 2/3, which equals 4. You must be very careful when doing the reciprocal. Notice here, this is a radical. It's a cube root. Since it's a cube root, we don't need a plus or minus, but if that was a 4th root, we would need to have a plus or minus on this. And that can be very deceptive, and one of the drawbacks of using exponents versus radicals. You're much less likely to forget the plus or minus when using radicals. So let's do one more. X minus 1 to the 1/4 plus 2 is equal to 0. So we can subtract 2 over. And now again, we want to cancel out the 1/4, so we're going to raise this to the 4th power. And when we do that, we get x minus 1 is equal to negative 2 to the 4th power, which is 16. So x equals 17. So tomorrow we'll pick up with this a little bit more. For tonight's homework, you have page 174, numbers 37 and 39, and page 177, numbers 1 to 11 odd, 17 and 29. See you all tomorrow.